For centuries, we've treated spacetime as a quiet background where matter and energy perform their physics. But at the sub-Planckian level, this model fractures, producing infinite division by zero errors that break our fundamental equations. To stop these coordinate crashes, the Adelic Langlands Program unloads infinitely divisible classical manifolds entirely. By replacing smooth space with discrete p-adic domains, the math provides a foundational grain to reality, preventing the calculations from ever hitting zero. This flowchart illustrates the result of that shift, a reality rendering pipeline. In this framework, the universe functions as a colossal computer graphics engine, translating abstract mathematical data into the physical world you perceive. The hardware of this system is the global Adelic Ring. It provides a mathematical arena devoid of physical matter, where arithmetic data sheaves bridge the gap between continuous manifolds and discrete number-theoretic domains. To see how this engine actually builds our world, we can track a single piece of pure data as it moves through the pipeline to compile into a physical state. The rendering process begins with observation. Spectral projection theory dictates that conscious attention acts as an active operator, injecting a specific mathematical perturbation into the underlying source code. This equation defines the localized consciousness operator. It tracks exactly how an observer's focus interacts with the Barry-Kanas Hamiltonian, modulating the Riemann Zeta function to create a customized spatial render. This interaction generates phase noise. If these localized observer errors accumulate, the mathematical consistency of the region diverges, leading to a system-wide reality crash. J-theory prevents this collapse by acting as a cooling chamber. As shown in the liquid-derived tensor product equation, the system buffers these volatile observer errors into liquid vector spaces, dampening the phase noise before it can break the loop. While conscious observation is inherently disruptive to the mathematical base layer, the universe employs this functional analytic immune system to stabilize reality in real time. Once the data is stabilized, it enters logos field theory, the universe's ultimate graphics engine. The Grothendieck-Riemann-Roch push-forward theorem is the mechanism for this projection. It forces abstract data from the top layer to intertwine with the classical 4D manifold below. The heavy downward arrow is the Grothendieck functor, the compiler physically pushing arithmetic data into a physical format. As the math resolves, its topological invariants map directly onto physical invariants. This Chern character expansion shows how degree 1 and degree 2 terms define topological multiplicity, which we experience as electric charge and magnetic flux density. Matter and physical forces are the necessary outputs of this compilation, the result of arithmetic data resolving itself into our four-dimensional spacetime. However, this pipeline faces a paradox. If the mathematical engine achieves perfect coherence, the universe suffers a metric lock. This quarantine firewall equation illustrates the consequence. At perfect efficiency, the system reaches zero entropy, and reality flash freezes into a Scholzy diamond, an isolated arithmetic singularity where all time and movement stop. The finalized master equation resolves this by building a defense against perfection into the source code. Note the 0.99 coefficient on the far left, scaling the dissonance evolution. This 1% lag break introduces an irreducible processing latency. It prevents the structural solidification seen on the left, keeping the computational river in motion. This latency creates a mathematical viscosity. The arithmetic data sheaf struggles through this buffer, creating a constant internal resistance. This structural hydrodynamic drag manifests as the curvature and acceleration we call gravity. As the data sheaf is pushed forward through the rendering engine, the 1% viscosity warps the geometry of the physical manifold. Every time you drop an object, you are physically experiencing the processing lag of a universal engine, continuously rendering the world around you.